Hello learners, good day. We are the group 2. So for this video, we're gonna be doing the lab exercise number 3 or the Arduino's basic input and output. So for this video, we're gonna answer 5 different problems. So let's get started. For the pre-lab task, we are assigned to write 3 different programs for the Arduino as described below. So we are also making sure to include an initial block of comments at the start of each program as well as comment throughout. We're gonna compile each program using the Arduino IDE and correct any errors that occur. So let's start with the program 1A. So we're gonna write a program to blink an LED on pin N as shown in the circuit. The circuit is in here in the introduction. And next, the LED should blink 1 time per second, 0.5 seconds on and 0.5 seconds off indefinitely. So we're gonna draw a schematic using the Tinkercad or FritzSync software. We're gonna create this video demonstration, and for the documentation, we're gonna provide the URL link of this video and cut and paste a screen snapshot of this final running circuit. So let's start. So for the first program or program 1A, we're gonna open the Arduino IDE. So let's start coding. Here in the top of the void setup, we're gonna first define the pin for the LED. So where the LED is assigned. So we're gonna call constant int LED pin is equals to 11. So for the 11 pin will be used. Next, for the inside the setup, we're gonna initialize the digital pin as an output. So we're gonna add pin mode. We're gonna call the LED pin variable and set it on the output state. Okay? For the void loop, so we're gonna turn the LED on high state for only 0.5 seconds. So we're gonna make digital write, gonna call again the LED pin and set it to high, and we're gonna add delay or value of 500, or 500 is equals to 0.5 seconds. I'm just gonna copy this line 9 to 12 to make for the LED when on low state for 0.5 seconds. We're gonna change to low, digital write set to low, and same delay number or value. So that's it for the program 1A. So I'm gonna pass this for the output checking to Daniela Velasquez. So take it away.
Good day everybody. So welcome back to another Arduino demonstration. So today we have a lot of circuitry to test. So let's begin. Okay, so before anything else, before we head on to the hardware or the actual testing on the Arduino Uno, we opted to simulate the circuitry first on Tinkercad. So let us see here. So before we test anything, I think I should first build the LED circuitry here on the breadboard. So as you can see, I have my materials here. First, let me put a green LED light here. So we have this. Let's put it over here. Okay, so after that, let me get my 220 resistor. Is this the two? I think it is. So putting the resistor on the negative. Negative. Okay, so a black cable to represent the negative, the ground part of the. Well, let me connect that to that, and then it was instructed here to put it on the 11th pin. Is this 11? 11th pin of the Arduino. Another wire to connect it to the ground. So let's use this one for the ground of the breadboard. Ground of the Arduino. So that should be it. Okay, let's move on over to the Arduino. This one. Okay, let me plug in my. There we go. Okay, so I had previously uploaded the code, so this is already working. Is it uploading? Yes, it is uploaded. So as you can see here, our board is working. There you go.
So for the next one, look for the program 1B. We're gonna write a program to the 3 LEDs shown in circuit 2 in sequence. So the circuit is telling is in here in the introduction with 220 ohms resistors with N plus 1, and N plus 2. So we're gonna turn on the LED N for 1 second while the others off. Then turn on LED N plus 1 for 1 second with the others off, and then turn on LED N plus 2 for 1 second and with the others turned off. We're gonna repeat this exactly at 10 times, so the total of this is around 30 seconds. So we're gonna draw again the schematic, create this video demo, and add and provide a screen snapshot. So let's get started. We're gonna open the Arduino IDE for the problem 1B. So for the top of the board setup, we're gonna be doing the int LED delay as the variable and set it to 1000 or 1 second. Next, on the board setup, we're gonna add a pin mode for the 3 LED. Pin mode 13, set it to output, and I'm just gonna copy the line 3. With pin mode and line 5. I'm gonna set it to 13, 12, and also 11. Next, for the void loop, we're gonna start a for loop. We're gonna start a for loop here for int and add a condition. Int I is equals to 0. Okay. And I is less than 10. And I plus plus, bracket. We're gonna add the inside of it digital write, the LED assigned to the 13 pin, and set it to high. And next, and we're gonna add the delay and called LED delay. This will simply wait for the delay or the animation speed of the LED. Of course, in milliseconds. So 1000 milliseconds equals to 1 second. So next, I'm just gonna copy this. And set it to low state. Next, same goes with the digital write on the LED on the 12 pin and on the 11 pin. We're gonna set high and also the low. Just copy this. I'm gonna change this to 12 and also here. And lastly, for the 11 pin, 11 and 11. Next, to satisfy this condition, I will also add a while loop in below here. While it is being true, while true, the program is continuing to light up the 3 different LED lights and satisfy the condition on the problem. So that's it from the problem 1B. So Daniela, take it away.
So now for problem 1B, let us try. Okay, so it is required for this. So one cable for the yellow line, one for red, then one for green. This time, let us try connecting these two so that you can also have connection on the other half of the breadboard. That's good. Okay, so connecting the red to the 13th pin to the 12. Okay, so that's that. Okay, so let's try step right now. Okay, it is so uploading. What is this? Oh, I forgot to connect it to the ground and the 5 volt. There you go. Okay, so just like in the simulation. What is it? Okay, starting. Okay. But it was working, right? So that's my simulation for problem 1B. Just like in the Tinkercad simulation, the Arduino R3 is carrying out lighting torch. So that's that.
Lastly, for the program 1C, we're gonna write a program that uses a function blink k m to make the LED pin K exactly m times, or 5.5 seconds on and 0.5 seconds off. So for example, the command blink 57 should make an LED on pin 5 blink 7 times. So the program should call blink 3 times from setup to do the following. So for the first condition, we're gonna make the first LED on pin N blink 4 times, then make pin on N plus 1 blink 6 times, and then we're gonna make the LED on pin N plus 2 blink only 3 times. So we're gonna go to the Arduino IDE and start writing the program. So for the first one, we're gonna add the function that will be to make the blink of the LED connected on pin K, M times, okay, so we're gonna add the void blink, okay, add the bracket, and inside of it is the inside of the parenthesis is the, we're gonna call int K and also int M. So inside the bracket, we're gonna add the for loop for int I is equals to 0 and int or I is less than M, and I plus plus, add the bracket, and we're gonna add the digital write and set the K to high state or turned on. So for this one, I'll add the comment to turn, wait, this will turn the LED on. Next, we're gonna add the delay. The value is 500 millisecond or 0.5 seconds as stated on the problem. Next, digital write, K to low state. This will be the opposite side of the LED, and this will turn off the LED. And we're gonna also add a delay of 0.5 seconds. Next, inside the void setup, we're gonna add the initial value. Initial value will be set to N, called N, and set it to 5 or the PIP pin. So the starting pin. Next, we're gonna be initialize pins as output. Next, we're gonna add the pin mode called N or the PIP pin, and next, and set it to output state. I'm just gonna copy the line 15, paste. Gonna arrange the indentation. This will be the N plus 1, and this will be the N plus 2. Okay. Next, we're gonna make the blink the LED on pin 5 4 times. So we're gonna blink N and 4. The 4 is the times where the LED will be blinking. Same goes with the N plus 1 and N plus 2. Just copy this, paste and paste. Just gonna edit some parts of the code, pin 6 and pin number 7 or 5 plus 2 and plus 1 and change it to gonna change it to 6 times, and the line 25 gonna change it to 3 times, and plus 2 change it to 6. Okay, so we are now done with the setup and the blink. For the void loop, we have nothing to do here, so we're not doing a loop on the program, since we are stating the number of times where the LED will be blink. So we're gonna add nothing to do. Okay, so that's it for the problem or program 1C. So thank you for listening, or I'll be passing this for the program output to Daniela. So take it away.
Okay, so moving on to another demonstration. So problem 1C has the same layout just as problem 1B. So we should utilize the existing circuitry. So I just moved from pins 11, 12, and 13 to 5, 6, and 7. And then I removed the 5 volt and ground power, and I replaced it with a ground from the digital pins and connected it to the negative part of the board. So let us move on to the code. Is this C? Yes, this is C. Let me just upload the code and let's see if it works. Okay, so as you can see, it is working. Green, yellow, and red are all blinking on the right sequence. Okay, so let us run it for another. Okay, just like the simulation, it is successfully working.
For this second problem, we are challenged to turn an LED off and on. The LED should be programmed to blink and should be on for 0.75 seconds and off for another 0.75 seconds as well. But how do we put that into code? Let's head over to our Arduino IDE. First things first, let's define a constant variable LED pin and set it to 4, which represents the digital pin where our LED component is connected to. Since we are the second group, this makes our pin number 4 according to the instructions. So let's just write it like so. Don't forget the semicolon. And the next, it's time to set up our program. Let's initialize LED pin as an output pin using pin mode to indicate that it will be used to output electric signals to the LED. Pin mode with inputs LED pin and output. And for the loop function, we'll alternate between turning the LED on and off with a delay of 0.75 seconds each. And we'll use digital write with 2 inputs, LED pin and high, to indicate the on status of the LED. And then let's use a delay of 750 to indicate how long it will stay in that state, being 750 milliseconds. And don't forget the semicolons. Like that. And we'll do the same for the off state, so let's just copy and paste it. But this time, we'll change the parameters of digital height to LED pin and low to represent the off status of the LED. And let's just keep the delay the same. And finally, we will use digital write with the off inputs, which is the low, the LED pin and the low. Then while input is true, like so, while with input true. This will make it so that after blinking once, it will turn off the LED forever and enter an infinite loop, effectively stopping further execution of the program. And that's basically the breakdown of program 2. Now, let's see how this works in action on our Arduino board.
moving on to problem 2. Okay, so just like what we have done in problem 1A, we just connected a single colored LED light to the board, connect a resistor to another, it's another end, connect to the negative. See? Okay, so this should work. Okay, so let us run the code for problem 2, upload it. So didn't I move it to, oh, should be moving it to pin 4. Let me just reset. There you go. I think it should be blinking in slow. There you go. So problem 2 is working properly on the actual Arduino board.
Now, let's move on to program 3, where we'll make 2 LEDs blink back and forth. Let's head on over once again to Arduino IDE to set up the code. And now for the code, let's first define 2 constant variables. We'll set LED pin 1 to 4, and then we'll set LED pin 2 to 5. These represent the digital pins where our LEDs are connected to, and these are also the correct pin numbers according to the instructions. And then next, in the setup function, we will initialize both pins as output pins. So let's do it using pin mode, LED pin 1 and output. And we'll just copy and paste it for LED pin 2. And now, for the main loop, we will use the same digital write command with LED pin 1 and set it to high. Let's copy the same command, but let's change it to LED pin 2 and low. Basically the opposite. LED pin 2 and low. This is so that when LED 1 is on, LED 2 is off, thereby alternating the state of the two. And then we'll set their delay to 750, being 0.75 seconds. And this is so that it will wait 0.75 seconds before executing the next command. And now, we can just copy the first part and alternate it, basically. So for LED pin 1, instead of being set to high, let's change it to low. And likewise for LED pin 2, from low to high. And we'll set the same delay, so no need to change it. And as you'll see in the demo part later on, we've successfully created a back and forth blinking effect between the two LEDs. It's time to upload it to our Arduino board to see how it works.
Okay, so another problem, we're moving on to problem number 3. So we'll be using a yellow and a green LED. So then we use this existing arrangement and another green. So this one is a green. We'll be moving the pin to pin 4 and then pin 5. Pin 4, 1 resistor is needed. Use this one. Okay, and then we'll be connecting from the power of the Arduino to the ground of the board and the 5V to the positive volt part of the board. Okay, let me see which code this one is. TP3. This is problem 3. Let us try uploading. Let's see. Should they be both? Oh, they should be switching. So this is 4 and 5. Let's see. Put the negative. I'm gonna try to. But they should be switching, right? Oh. This has been 4 and 5, yes. Oh, okay. So let me try switching this to the third. Why aren't they? There shouldn't be a problem with that. But because it's working. Maybe try moving it to this side. Okay, so there was some. There you go. Okay, just like in the simulation. Okay, so that's done.
In program number 4, we are challenged with developing a traffic light simulation using an Arduino microcontroller. Traffic lights play a crucial role in managing traffic flow at intersections, ensuring the safety of both drivers and pedestrians. By simulating a traffic light system, we can gain a deeper understanding of how such systems function and how to control electronic components using an Arduino. The goal is to connect the 3 LEDs, which are green, yellow, and red, and 3 220 ohms resistors to the digital output pins of an Arduino. We will write a program that simulates a traffic light by turning the green LED on for 10 seconds, the yellow LED on for 1 second, and the red LED on for 8 seconds. This sequence will repeat indefinitely, mimicking the continuous operation of a real traffic light. So let's walk through the complete Arduino source code for the traffic light system. First, we need to define which pins the LEDs will be connected to. We'll assign each LED, which are green, yellow, and red, to a specific digital output pin on the Arduino. So let's type const int green LED pin equals 11. Then yellow LED pin equals 12. Then last, for the red LED pin, so these are the pins connected to the 3 LED lights, which are the green, yellow, and the red. Now, we will set up these pins as output in the setup function. The setup function runs once when you press reset or power the board. So let's initialize the digital pins as outputs. Pin mode. For green LED pin, next output. So let's just copy this line. And let's paste it. And last, the second line, let's change it, make it yellow LED pin, then red LED pin. So that's for the setup function. Finally, we'll write the loop function to control the timing and sequence of the LEDs simulating the operation of a traffic light. In the loop function, we will control the sequence of the LEDs. The green LED will turn on for 10 seconds, followed by the yellow LED for 1 second, and finally the red LED for 8 seconds. This cycle will repeat indefinitely. So, the loop function runs over and over again forever. So, for the green LED, let's type digital write. For green LED pin, then high. This will turn the green LED on. And for the delay, let's type 10,000. And next, let's type digital write. Then green LED pin and low. This will turn the green LED off. And for the next color, turn the yellow LED on for 1 second. Let's type digital write. For yellow LED pin and high. This will turn the yellow LED on. And for the delay, let's type 1000. This will wait for 1 second. And for digital write, for yellow LED pin, and then low, this will turn the yellow LED off. And for the next color, which is the red LED pin, let's type digital write, red LED pin, and high to turn the red LED on. Next is delay, 8000 to wait for 8 seconds. Then next is to turn the red LED off.
Okay, so for problem 4, we are... How do we do this? Okay, so another 3 LED lights. So using red. So red, yellow, red, yellow, and so we'll be using red, yellow, and green. Okay, so another resistor is needed here. Okay, so the cable should be connected to pins 11, 12, and 13 again. So it should be connected to 13. 13. Is this 13? So this. So a yellow one for pin 12. Up. There we go. And let's look for the code. This is problem 4. Where the code? Oh, it should still be the same. Okay, so I think it works. Yes, it works. It's working. Okay, so that is okay.
For program number 5, named Switch Control Running Light Effects, I will demonstrate to you on how to manually write this code and also discuss its functionalities, its overview, its requirements, and hardware setup, and also the Arduino's basic inputs and outputs through Arduino IDE, showing right here on the right screen. So let's get started. For the program, in this project we are working with an Arduino board to control a series of red and green LEDs through a menu-driven interface accessed via a serial monitor. The project utilizes digital input from toggle switches or push-button switches to select different LED lighting sequences. This demonstration explains each section of the code and the interaction between the hardware and software components. So, the requirements of this setup requires Arduino board, breadboard, 4 red LEDs, 4 green LEDs, 8 resistors, typically 220 ohms for each LED, 5 push buttons or toggle switches, and jumper wires. So, for the software development, we will define pin numbers, we will set up the functions, we will set up the loop function, we will have the LED sequence functions, mode 1, mode 2, mode 3, mode 4, as we can see here in the running light effects menu. Also, take note of this, each light sequence mode is a static algorithm, and it cannot be altered unless it will be modified through the code. So we have mode 1, we have mode 2, mode 3, and mode 4, and also the DIY setup. Now I will also introduce to you the advanced functions such as the debounce delay and utility functions, and also talk about the complexity and efficiency of the code. So let's get started. Step 1, you need to set up the Arduino environment. Step 2, we need to define constants and variables. So we need to define pin numbers for LEDs. So constant int red LEDs two, 3, 4, and 5, assuming red LEDs are connected to pins 2, 3, 4, and 5. I'm sorry. So next is constant int green LEDs with pin numbers 6, 7, 8, and 9, assuming green LEDs are connected to pins 6, 7, 8, 9. So that's basically what we need. And also define, let's add a comment, define pin numbers for toggle switches or push button switches. Constant int switch pins equals array 10, 11, 12, 13, and A0. Assuming switches are connected to pins 10, 11, 12, 13, and A0. So that's for the step number 2. These constant ints are keywords that ensure the pin assignments do not change. And I also defined arrays to hold the pin numbers for the red and green LEDs and the switch inputs, so that it will be constant and it will define what pin numbers are connected to jumper wires for the setup of our algorithm. Step 3, we need to configure the setup. So we will have this initialize LED pins as outputs for, let's add a for loop for int I equals 0, I is less than 4, then I increment. We will add a bracket here, braces, curly braces I mean, pin mode switch pins I input pull up. And let's add serial begin, start serial communication, serial.print ln, and let's add this text. Let's add the push button 1. Wait. After adding this serial print in line or code block, we will also introduce the push button for our serial monitor menu. Push button 1, light sequence mode 1. Also mode 2, mode 3, mode 4. And also the DIY mode. push 2, push 3, push 4, and push 5. So basically, that's all what we need for our step 3, configuring the setup. So it starts with the serial communication at 9600 bits per second to send data or data to the computer. It also configures the LEDs as outputs to control the LEDs. The LED pins, I mean. It also configures the switch pins as input with pull-up resistors, meaning the default state is high and goes low when pressed. It also sends a startup message to the serial monitor. So let's go ahead and go to step 4, which is creating the main loop. In loop function. So the code is void loop check each switch button for int I equals 0, I is less than 5, and I increment curly braces if digital read switch pins is equal to low, button pressed, serial print in mode, pick an option. Serial print ln I plus 1, display the option number. After that, we also need to have a switch, curly braces, case 0, light sequence mode 1, break. Also have the basically we just need to copy this case 2, case 3, case 4, 1, 2, 3, and 4. Also indent this one. Just like that. Mode 2, mode 3, mode 4, and DIY mode. After having the cases, after configuring the cases, as parameters, we will have the default serial.println invalid option. Please pick a valid option. Just like that. After that, I will have comment here. Wait until button is released. While digital read switch pins I is equal to low. Wait. That is it for our main loop. I also reviewed here if everything goes, there is any mistakes. Case 0, case 1, case 2, case 3, and case 4. So that's it for the step 4. So for the step 4, the function of this is continuously checks each switch to see if it has been pressed. Checks if the state is low. When a button is pressed, it prints which mode has been selected and executes the corresponding LED sequence. And it waits for the button to be released before continuing to prevent multiple triggers. So this is the function. Next, for the step 5, we will introduce implementing light sequence functions. So for void loop, we will also have the void loop. Void light sequence mode. 1 curly braces for int I equals 0, I is less than 4, I increment, then curly braces, digital write, and red LEDs, high mode, comma high, delay 500, and also digital write, red LEDs, I, low. Copy this one. Do it for green LEDs. The delay is also 500. Basically, red LEDs, high, low, high, low. Let's copy this one for void light sequence mode 2. Red LEDs and green LEDs. Three minus I, and the delay is 250. And for the delay is 250, digital write is red LEDs, high, low, and also for green LEDs, P minus I, low. So this is for the setup. For void light sequence mode 3, for J is equals to 0, J is less than 3, and J increment. We will have a also for loop int I equals 0, I less than 255, and I is equals plus 5, analog write red LEDs 0. This is the parameters. 1, 2, and 3. Green LEDs 0, 1, 2, and 3. Also, we will need to have an extra for in here. No, here. I equals 255. I is greater than or equal to 0. Minus or equal to 5. Analog write read 0, 1, 2, 3 means 1, 2, 3. Okay, let me check. Okay, that's it for void light sequence 3. We will go ahead and for light sequence mode 4. So for int, let me revise everything. For int, I equals 0, I is less than 20, I plus plus, or I increment is int index random 0 4. Digital write red LEDs rand index is high. Digital write green LEDs rand index high. Delay random 50 and 250. Digital write red LEDs rand index low. For the greens, I also have delay here. Delay random 50 and 250. So basically that is it for light sequence mode 4. And for light sequence mode DIY for myself, I will introduce int sequence. Int sequence equals 0 while sequence is not equal to 3. I will have a serial println press a button to select color. 1 for red, 2 for green, 3 to exit DIY mode. That's it. Wait for a button press while true. For int I equals 0, I is less than 5 and I increment. If digital read switch pins I is equal to low, then break I sequence I plus 1, break if sequence is not equal to 0, break. Execute corresponding action based on button press. Switch sequence curly braces case 1 custom red LED sequence. For int I equals 0, I is less than 4, and I increment. Curly braces again. Digital write red LEDs I high. Delay is 500. Digital write red LEDs high. Low. We'll have break here for case 2. Custom green LED sequence. Green LEDs. Green LEDs. For case 3. Case 3 break. break. Just like that. Wait, let me go ahead and have serial print ln exiting DIY mode. Break. Default. Serial print ln invalid input. Press 1 for red, 2 for green, 3 to exit DIY mode. Break. Delay is 100. The bounce delay. So basically, this is for the step 5, the light sequence mode. Each function controls a different lighting pattern or sequence. So as you can see here in void light sequence mode 1, we have different algorithms here. Digital write, also same as the light sequence mode 2, light sequence mode 3, and light sequence mode 4, and also for the DIY mode. Next, we use digital write to turn LEDs on and off. So high is always indicates turn on state, and low indicates turn off state. We also use delay here and random to manage the timing of the lighting effects. So when one green LED is turned on, we will have a delay with 250, and the second green LED will turn on as well. So it has a sequence 250 delay. Next step is we will now compile. Step 6, we will compile and upload the program. So we will have void turn on, red LEDs, turn on red LEDs. For int I equals 0, I is less than 4, and I plus plus or I increment, we will have a digital write again, red LEDs, I, parameter high. That is the argument that we need. Next, wait for a short duration, delay 1000, turn off all LEDs, turn off all LEDs, just like that. Next, we'll have void turn on green LEDs, turn on green LEDs. For int I equals 0, I is less than 4, I plus plus, I increment, digital write, green LEDs, high, so turn on to high the argument, wait for a short duration, delay 1000, turn off all LEDs, then turn off all LEDs. We will also have a void We will also have a void turn off all LEDs. Turn off all LEDs. For and I equals 0, I is less than 4, then I increment. Really braces digital right, red LEDs. I'm sorry. Low. Also, digital right, green LEDs. Low. Basically, that's it for our program. We will need to upload this. And Daniela Francine Velasquez will test the output for this code. So, this code process encapsulates the entirety of writing, testing, and refining an Arduino program to control LEDs through button inputs. Each step builds upon the previous one, ensuring a structured approach to hardware programming with clear outputs and user interaction. So that's it for the input of our basic Arduino input and output. I will move ahead and give this title to Daniela Francine Velasquez for testing the output. Thank you, everyone.
Moving on to the last problem, we have this traffic light circuit. So let me first build this circuitry on my Arduino board. So for the power, we have just that. And I think I have been encountering a problem here, and let me use some more cables. Let me use this. I won't be color coding today because we have a lack of materials, but let me just connect these two because I am having a problem with it. Okay. Am I recording? Okay. There you go. So let's build the circuitry. So we'll be needing 4 red LED. So this is one. This is it 2? Yes, this is the second one. And the last 4. This is scratched out. Okay. So, and then 4 corresponding resistors. Then one last resistor. There you go. So for the next part, we have 4 green, red, 1, 2, 4. So, oh no, so 1, 2, 3, it's 5 buttons. That is 5. Let me move this over here just so my 5 buttons can fit. This is 220. This is 1 key. So 3 more resistors to connect. LED. We have this. this one. And then this one. Okay, let us now set up our buttons. So I have my 5 buttons here. 1, 2, 4, and 5. Let me just connect it to positive and positive. And then another for negative. Okay, so should be corresponding for the positive, right? And it's still, it is for the ground. One here, one here, another for this. Another, and then last. No, so I should still be putting cables in 8. This is 3. 1, 2, 3, 4. So for the green one, for the first green, it is connected to the 9th. It's the 9th pin. 8 and the 9. The second for the 8th pin. Eighth. So the third is for the 7th. 7. It's for the 6th. Okay, and then the pin for the first is connected to the 5th. And so it's just in the second order. Right. Should be clear there. Yep. Okay, and for the last one, we have it connected to the... Okay. Okay, so that's that. What else? Oh! The pins of the buttons. That's 5, right? 5, 4. Okay. So one here for this. One is for the 13th pin. 13th? 13th? Yes, you are. The other one for the 12th. 12th. 11th. And then I guess it's yeah. Okay, let us now try loading the code. Wait, let me add 2 more wires here. Just so we can connect. Okay, here's my... Okay, so just like in the simulation, I think we made it work. That's that. Thank you for watching and don't forget to subscribe.